Right now, as you are watching this, more than 100 million Americans are living underneath the second of two separate heat domes that have taken turns crushing this country since the last week of June. Phoenix, Arizona broke an August record on the 2nd, hitting 115 degrees. Las Vegas reached 115 degrees on the 1st of August, 1 single degree short of the daily record for that date. El Centro, California was forecast to hit 118. Across the West, roughly 55 million people sat under heat alerts that stretched from the Mexican border all the way north to the Canadian line into Montana and North Dakota. And back on the 4th of July, on the completely opposite side of the country, Atlantic City, New Jersey, tied the hottest temperature ever recorded in that city, 106 degrees, while Philadelphia stacked up 3 consecutive days above 101 degrees for the first time in the city's recorded history. Between June 30th and July 5th alone, at least 148 daily high temperature records fell across the United States. This is not normal news cycle noise. Something significant is happening across the American heat map simultaneously in the east and in the west inside the same single summer, and the calendar still has a great deal of that summer left on it. Today we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. And by the time we are done here, you will understand exactly which single number the forecasters are actually watching to decide whether this becomes much worse for America. I will tell you right now that it is not the daytime high number sitting on your phone screen. It is a different number entirely. It is measured at the wrong end of the day, and almost nobody outside the National Weather Service is paying attention to it. Drop a comment right now. Have you ever personally lived through a heat wave that genuinely scared you? Tell me where you were and what it actually felt like. I read these. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to the people who need to see it. Now, let us get into it. To understand where this is heading, you have to go back to the 11th of June, 2026, because that is the day this summer stopped being a normal summer on paper. That was the day the National Oceanic and Atmospheric Administration formally announced that El Nino conditions had developed in the tropical Pacific Ocean and issued an El Nino advisory. El Nino is the warm phase of a natural climate oscillation. Every 3 to 5 years, a vast pool of water in the central and eastern equatorial Pacific runs warmer than average, and because the ocean and the atmosphere are locked together, that warm water reorganizes weather patterns across the entire planet. NOAA declares an El Nino when those equatorial Pacific temperatures run half a degree Celsius above average for several consecutive months. On June 11th, they crossed that line. And in the same announcement, forecasters put a 63% probability on this event, eventually exceeding 2 full degrees Celsius above average, which is the threshold that gets an event labeled very strong, or in the language most meteorologists actually use, a super El Nino. There have been only 5 of those since 1950, 1972 to 73, 1982 to 83, 1991 to 92, 1997 to 98, and 2015 to 2016. That is it. 5 events in 76 years of modern record keeping. 2.5 weeks after that advisory, the first dome arrived. On June 26th, meteorologists began warning that a widespread searing ridge of high pressure was settling over the central and eastern United States. By June 29th, forecasters were describing the hottest temperatures in more than a decade as a genuine threat for parts of the eastern United States, with the dome expanding and intensifying. And by the time it locked into place, nearly half of the United States, approximately 180 million people, was sitting under a major or extreme heat risk designation from the National Weather Service. Temperatures were forecast to reach between 100 and 110 degrees across enormous stretches of the map. The timing could not have been worse. That dome parked itself over the eastern half of the continent from roughly June 28th through July 5th, which is to say it covered Independence Day weekend, it covered FIFA World Cup matches being played at East Coast venues, and it covered outdoor fairs and public celebrations where hundreds of thousands of people had already committed to standing outside in the sun. Players and spectators were forced into repeated shade and hydration breaks. Public services buckled. Transit systems reported delays because rail infrastructure does not behave predictably at those temperatures. Hundreds of thousands of homes lost power for part of the event, and the records fell in a cluster. On July 4th, Atlantic City, New Jersey hit 106 degrees, tying its all-time hottest temperature ever recorded. Not its hottest July 4th, its hottest anything. Philadelphia recorded 3 consecutive days above 101 degrees, which had never once happened in that city's history. In New York City, a heat emergency plan was activated, and people packed the beaches at Coney Island simply because there was nowhere cooler to go. Across the 6-day window from June 30th to July 5th, that count of 148 daily high temperature records was set. Now, to be precise about what that number means, because this matters, a daily record high is a comparatively easy record to break. Every location has 365 of them, and any given station might break several in a hot year without that being remarkable. What is remarkable is the density and the geography. 148 of them inside 6 days, spread across a huge portion of a continent, is a signature of a single enormous synoptic scale feature, not a collection of local flukes. North of the border, the same dome produced a different failure mode. On July 1st, Canada Day, the extreme heat fed enormous thunderstorm complexes that produced widespread flooding and knocked out power to thousands of homes. That is a detail people consistently miss about heat domes. They do not only cook. When the edge of the dome finally gets undercut by cooler air, the atmosphere dumps all the energy it has been storing in one violent burst. Then the pattern did something that surprised a lot of people. It did not end, it moved. On July 15th, record heat came back to the northeast when Lehigh Valley International Airport in Pennsylvania hit 98 degrees, tying the daily record. And here is a genuinely strange detail from July 16th. The heating the next day was actually held back, suppressed by thick smoke drifting south from the Canadian wildfires. That is worth sitting with for a second. The smoke from one climate-amplified disaster was physically blocking enough sunlight to reduce the intensity of another one. That is not a comforting fact. That is a description of a system with multiple simultaneous problems interacting. Then, around July 22nd, southern Louisiana produced one of the most unusual advisory combinations in modern American weather history. As Tropical Storm Bertha moved through the Gulf, parts of southern Louisiana were placed under a tropical storm warning and an extreme heat warning at the same time. That had not happened since 2005. Think about what that actually means operationally. Emergency managers were simultaneously telling people to shelter from wind and surge, and telling them that being indoors without power in that heat could kill them. That changed fast. By the last days of July, the entire pattern had flipped to the western half of the continent, and the second dome, the one still influencing this country as you watch this, began to build. On July 24th, Arizona Public Service, the largest utility in Arizona, hit an all-time peak electricity demand record of 9,053 megawatts. On August 1st, the National Weather Service had roughly 55 million people under heat alerts across the West. Las Vegas reached 115 degrees, the hottest reading of its year to that point, missing the daily record by a single degree. Phoenix was forecast for 116 to 118. El Centro, California was forecast to hit a record 118. Downtown Los Angeles, which is normally buffered by the marine layer, sat under an extreme heat warning with cooling centers opened across the city. Heat alerts extended unbroken from the desert southwest through the Great Basin, over the Rockies, and up into Montana and the Dakotas. On August 2nd, Phoenix broke its record for the date at 115 degrees. That same evening, between 6 and 7 p.m., Arizona Public Service set a brand new all-time peak demand record of 9,164 megawatts, beating the record it had just set 9 days earlier by more than 100 megawatts. Salt River Project, the other major valley utility, also set records that month. When you hear that a grid set a new all-time peak twice inside 10 days, what you are hearing is a system operating at the top of its designed envelope, repeatedly, with no margin left for a surprise. By August 5th, the National Weather Service office in Phoenix had extended its extreme heat warning through 8 p.m. on Sunday, August 9th, with valley highs running 106 to 114 degrees and a forecast peak near 113 on Friday and Saturday. But the detail buried in that same forecast discussion was the one that actually matters, and I want you to hear it clearly. High humidity was moving in, and overnight morning lows were forecast to stay in the low 90s. Hold on to that. We are coming back to it because that is the number I promised you. Meanwhile, the same ridge was doing something else entirely to the Pacific Northwest. Extreme fire danger, a rare level 3 out of 3, extremely critical designation was posted for portions of Washington and Oregon. Washington's governor implemented a statewide burn ban. Thousands of residents in Spokane County were placed under evacuation orders as the Old Trails fire ran through the landscape, and by early August, incident commanders were describing the loss in terms of hundreds of destroyed structures and tens of thousands of evacuees. On August 4th, investigators ruled the Old Trails fire an arson and arrested a 37-year-old man on a $1 million bond. Nationally, the interagency fire system was operating at preparedness level 5, the top of the scale, with dozens of uncontained large fires burning at once and total acreage for the year running well above the 10-year average. Oregon, meanwhile, was having its own historic year, with total burned acreage climbing past 2 million acres and closing in on the state's 2024 record. Nationally, the picture was a fire season running roughly a third above the 10-year average for acres burned, in a summer where the same ridge that was cooking Phoenix was also drying out the fuels in Washington, Oregon, Idaho, and Montana. That is the compounding relationship people miss. The heat dome does not just cause heat, it manufactures fire weather several states away from where the record temperature is being set, and then the smoke from that fire travels 1,000 miles and lands on a population already under cardiovascular strain. And through all of it, the deaths accumulated quietly, the way heat deaths always do. As of August 5th, 2026, roughly 70 deaths had been attributed to this North American heat wave in the aggregate reporting. In Maricopa County, Arizona alone, which counts more carefully than almost anywhere else in America, public health officials had confirmed 51 heat-related deaths for the season, more than twice the number confirmed at the same point the previous year. And confirmed is the key word there. Earlier in the summer, on July 8th, the county had 18 confirmed deaths and 215 additional deaths still under investigation. The confirmations lag the reality by weeks and sometimes months. The number you read in August is never the number that ends up in the annual report. So that is the reconstruction. 2 domes, 1 continent, 6 weeks, 148 records in a single week, 2 all-time grid peaks in 10 days, a level 3 fire emergency, and a death count that is still being counted. But here's the part that actually explains why forecasters are not relaxing. To understand why this is happening, and more importantly, why it may not be finished, you have to understand what a heat dome actually is, because the term gets thrown around on television without anyone explaining the physics. A heat dome is not a thing. It is a shape. Specifically, it is a large, persistent ridge of high pressure sitting in the upper atmosphere. Inside a high-pressure system, air sinks. And air that sinks gets compressed, and air that gets compressed gets hotter. This is not a subtle effect. It is the same principle that makes a bicycle pump warm in your hand when you inflate a tire. The atmosphere is doing that over and over across a footprint the size of a dozen states for days on end. The sinking air does a second thing that is arguably worse. It suppresses cloud formation. Clouds need rising air. When the air is sinking, you get a clear sky, which means the full unfiltered solar load hits the ground every single day, and the ground bakes. Each day of the event, the soil gets drier and the surface gets hotter, and because there is less moisture left in the soil to evaporate, less of the incoming solar energy goes into evaporation, and more of it goes directly into heating the air. That is what meteorologists mean when they talk about a heat dome reinforcing itself. Day 3 is worse than day 1, not because the atmosphere changed, but because the ground did. But a ridge of high pressure by itself is not enough to produce a 6-week event across a continent. For that, you need the ridge to get stuck. And what determines whether a ridge gets stuck is the jet stream. The jet stream is a river of fast-moving air several miles above your head, driven by the temperature contrast between cold polar air and warm tropical air. It is what steers weather systems from west to east across North America. Normally it runs in relatively tight, fast, progressive waves, which is why a hot spell in Kansas becomes a hot spell in Ohio 3 days later and then dissolves. But when those waves grow tall and slow, the pattern can lock into what meteorologists call a blocking pattern, and the most stubborn variety is named the omega block, because on a map the flow traces the shape of the Greek letter omega, with a fat ridge in the middle and a low-pressure trough pinned on either side. A blocked pattern is the difference between a 3-day hot spell and a 9-day emergency. The ridge cannot move because there is nowhere for it to go. Every system approaching from the Pacific gets deflected around it. And underneath it, that self-reinforcing drying cycle we just described gets to run uninterrupted day after day until something large enough finally dislodges the whole configuration. That is why the American pattern this summer behaved the way it did. It did not weaken. It relocated. The Eastern Dome held from June 28th to July 5th. The pattern then reloaded, produced a second eastern spike around July 15th, and by the very end of July had rebuilt over the entire western half of the continent, where it has been holding through the first 10 days of August. That is not one heat wave. That is a persistent, large-scale circulation regime expressing itself in different places, and that distinction is the entire reason forecasters are not treating this as finished. There is one more piece of vocabulary worth knowing, because you will see it in every official alert now, and most people have no idea what it means. In recent years, the National Weather Service moved away from relying purely on temperature thresholds and rolled out a system called heat risk, which grades conditions on a 5-level color scale from little to no risk up through extreme. The reason it exists is that a 95-degree day in June in Minneapolis is a genuine public health emergency, and a 95-degree day in August in Phoenix is a Tuesday. Heat risk accounts for how unusual the heat is for that location and that time of year, how long it will last, whether the nights offer recovery, and whether the thresholds are ones that local health data show actually correlate with hospital visits. When you hear that 180 million Americans were under a major or extreme heat risk in early July, that is the scale being referenced. And it is a public health statement, not a thermometer statement. To put 115 degrees in context, human core body temperature is about 98.6 degrees. Your body sheds heat into the environment by simple physics. Heat flows from hot to cold. When the air around you is 115 degrees, that gradient runs backwards. The environment is now pushing heat into you. At that point, your body has exactly one remaining tool: evaporative cooling, sweat, and that is where humidity becomes the entire story. Sweat only cools you when it evaporates. If the air is already saturated with water vapor, evaporation slows to a crawl, and sweating becomes a way to lose fluid without losing heat. This is why meteorologists use the wet bulb temperature, literally the temperature read by a thermometer with a wet cloth wrapped around the bulb, which measures how much cooling evaporation can still deliver. It is a measure of how much escape route your body has left. A 115-degree day in dry Phoenix air and a 98-degree day in saturated Gulf Coast air can put similar or even comparable strain on a human body, and the second one catches far more people off guard because 98 does not sound frightening. Now hold that thought against something specific from the August 5th Phoenix forecast. High humidity moving into the valley during an extreme heat warning. That is monsoon moisture arriving on top of a heat dome. The daytime high number may actually come down slightly when that happens. The danger goes up. It is also worth knowing exactly what heat does to a body because the progression is specific and the warning signs are frequently misread as something else entirely. The first stage is heat exhaustion. Your body dilates the blood vessels near the skin to dump heat and diverts blood volume toward the surface, which means less blood is reaching the brain and the gut. That produces the classic signature heavy sweating, cool and clammy skin, dizziness, nausea, weakness, headache, a fast but weak pulse. A person in that state can usually be saved with nothing more sophisticated than shade, water, and time. Most people have felt some version of it and never thought twice about it. The second stage is heat stroke, and it is a genuine medical emergency with a mortality rate that climbs sharply with every minute of delay. The defining transition is that thermoregulation fails outright. Core temperature passes roughly 104 degrees. And here's the detail that fools people over and over. Sweating often stops. The skin goes hot and dry and red rather than clammy. Because the popular understanding is that sweating means overheating, a person who has stopped sweating frequently gets assessed as having recovered. They have not. They have crossed a line. Confusion, slurred speech, aggression, disorientation, and loss of consciousness follow. And because those symptoms look like intoxication or a stroke or simple crankiness, bystanders very often misdiagnose the one condition where minutes actually matter. The single most useful thing to know is that in an older adult, sudden confusion during a heat wave is a temperature emergency until proven otherwise. Not dehydration, not fatigue, not age, confusion. And that brings us to the number I promised you at the top, the overnight low. Here's the single most underreported fact in American heat safety. Heat is not primarily a daytime killer. It is a cumulative one. Your body can tolerate an extraordinary thermal load for a number of hours if, and only if, it gets a recovery window. Historically, that window is the night. Temperatures fall after sunset, the body offloads accumulated heat, cardiovascular strain resets, and you start the next day at baseline. Remove that window and the math changes completely. During the Western Dome, overnight lows in Phoenix and Las Vegas were only falling into the upper 80s and low 90s. A National Weather Service meteorologist described the situation plainly, saying that there was simply no relief overnight. When the low is 92 degrees, a person without air conditioning does not reset. They start day 2 already elevated and day 3 higher still, and somewhere around day 4 or 5, an underlying heart condition or kidney problem that had been perfectly manageable for 20 years stops being manageable. That is the actual mechanism by which heat waves kill people, and it is why the death curve in a long heat event does not track the peak temperature. It tracks the duration and the nighttime minimum. This is also why urban geography matters so much. Asphalt, concrete, and brick have high thermal mass. They absorb solar energy all day and release it slowly all night. A dense city block with no tree canopy can run 10 to 15 degrees warmer at 2 in the morning than a park 2 miles away. The people living on that block are, in a very literal sense, in a different climate than the airport where the official temperature is measured. But here is the part nobody expected this year. The reason forecasters are treating late summer and fall with unusual seriousness is not the heat domes themselves. Domes come and go. It is what the Pacific Ocean is doing underneath them. By late July, that El Nino that was declared on June 11th had already warmed past the 2 degrees Celsius threshold, 3.6 degrees Fahrenheit above averagers, and was running at a record pace for the calendar. The Climate Prediction Center's outlook put roughly an 81% chance on a very strong El Nino developing during the October through December window, with peak intensity most likely arriving in late fall or early winter and a 97% chance of the event persisting through the following spring. Some computer models suggested this could become the strongest El Nino since record-keeping began in 1950. Now, I want to be careful here because this is exactly the point where online content goes off the rails. El Nino does not simply mean hotter everywhere. That is not how it works, and any channel telling you otherwise is guessing. El Nino is a redistribution. It shifts the jet stream. It changes where storms track. It wets some regions and dries others. NOAA itself explicitly cautioned that a record-breaking event could produce atmospheric impacts that have never been observed before, and that stronger events do not produce typical impacts everywhere. They tilt the odds more heavily in favor of certain outcomes, which is a very different and much more honest statement. What we can say with reasonable confidence from the physics and from the analog years is this. First, El Nino increases upper-level westerly winds across the tropical Atlantic, which raises wind shear and statistically suppresses Atlantic hurricane activity. That is precisely why NOAA's August update reduced the seasonal forecast to 7 to 13 named storms, 2 to 6 hurricanes, and 0 to 2 major hurricanes, well below the average season's 14, 7, and 3. Second, the eastern and central Pacific basins tend to run busier, which increases tropical moisture reaching Hawaii, and through storm remnants, the desert southwest. And third, and this is the one that actually applies to the next several weeks, a suppressed Atlantic season means fewer frontal disruptions and fewer tropical systems breaking down established high-pressure ridges over the continental United States. Let me put that plainly. One of the natural mechanisms that historically breaks American heat waves is a tropical system or a strong frontal boundary shoving the ridge out of the way. Reduce the frequency of those, and ridges get to sit longer. Duration is the danger, not the peak. These are not just meteorological events, they are human experiences, and the difference between who lives through them and who does not is almost never luck. History has already run this experiment on us twice, in 2 very different American cities, and both results are worth knowing. In July of 1995, Chicago experienced a heat wave that killed an estimated 739 people in roughly 5 days. The peak temperature was 106 degrees. That is hot, but it is not extraordinary. Phoenix beats it casually. What made Chicago lethal was the combination the science has been pointing at this entire video. Extremely high humidity that pushed the heat index far above the air temperature, overnight lows that stayed in the 80s in a dense urban core built of brick and asphalt, and a housing stock where a large share of low-income and elderly residents had no air conditioning at all. Many of the dead were found days later alone, in apartments with the windows shut. Some had kept them shut because they were afraid of crime. That last detail is not a footnote. It is the whole finding. The subsequent sociological work on that disaster found that the strongest predictor of survival at the neighborhood level was not income and not even air conditioning access alone. It was social connection. Neighborhoods where people knew each other, where shops stayed open and streets stayed walkable, lost dramatically fewer residents than demographically similar neighborhoods where people were isolated. 2 adjacent Chicago neighborhoods with nearly identical poverty and elderly populations had death rates that differed by roughly a factor of 10. The difference was whether anyone knocked on the door. The second experiment ran in June of 2021 in a place that had no business experiencing it at all. A heat dome parked over the Pacific Northwest and British Columbia, a region where air conditioning was, at the time, absent from a majority of homes because it had simply never been necessary. Portland, Oregon reached 116 degrees, Seattle hit 108. The village of Lytton, British Columbia, recorded 121.3 degrees, the hottest temperature ever measured anywhere in Canada, in a country most Americans think of as a place you go to escape heat. The following day, Lytton was substantially destroyed by fire. Across the region, hundreds of people died, and the great majority of them died indoors, in their own homes, in a part of the world where nobody had ever needed to think about it. The lesson of Portland is the exact inverse of the lesson of Phoenix. Phoenix is dangerous because it is extremely hot. Portland was dangerous because it was unprepared. The difference between a survivable heat event and a mass casualty event is not the number on the thermometer. It is the gap between what the atmosphere delivers and what the built environment and the population were designed to absorb, which is why the most instructive American case of all is the one currently running. Consider Maricopa County, Arizona, because it is the closest thing America has to a controlled experiment on this question. In 2023, Phoenix endured 31 consecutive days at or above 110 degrees, obliterating the previous record of 18 consecutive days set back in 1974. That year, Maricopa County recorded 645 heat-associated deaths, the deadliest heat year in the county's history. Then something happened that almost nobody covered because good news does not travel. The county built out a heat response infrastructure, funded substantially through federal pandemic-era money starting in the summer of 2024. They expanded a heat relief network of free cooling spaces open from May through September. They set up a phone line, 211 dial, that would connect a person to an operator and, critically, arrange a free ride to air conditioning. Charitable organizations opened additional relief stations during extreme heat warnings. The county began closing hiking trails at Camelback Mountain, Pistewa Peak, and South Mountain during heat warnings because a shocking fraction of heat emergencies are healthy people who went for a hike. The deaths fell. 645 in 2023, 608 in 2024, and preliminary data for 2025 showed 427, 218 fewer deaths in 2 years. Not because the desert got cooler, it did not. Because a county decided that a heat death is a preventable death and then spent money accordingly. And now, hold that against 2026. This season started early. Abnormally warm spring temperatures produced confirmed heat deaths as far back as March, which county officials described as relatively early for that to begin. By July 2nd, 16 deaths were confirmed against 3 at the same point the prior year. By July 8th, 18 confirmed with 215 under investigation. By early August, 51 confirmed sparkstones, more than double the prior year's pace. A deputy director of the county health department put it in the only terms that really matter, saying those deaths are, of course, preventable. 2026 is also the final year of that expanded federal funding. I am not going to tell you what should happen next because that is a policy question and this is not a policy channel. But I will tell you what the data shows, and the data shows something unambiguous. The difference between 645 deaths and 427 deaths was not weather. It was cooling centers, a phone number, and free rides. Look at the demographics of who dies, and the picture sharpens further. In the county's detailed reporting from earlier years, the vast majority of heat-associated deaths occurred outdoors, and people experiencing homelessness made up a very large share of the total. Men died at roughly 3 times the rate of women. And the deaths clustered overwhelmingly into June, July, and August, with a meaningful additional share in September, when triple-digit days are still common but public attention has already moved on. That September detail is the one I want you to remember. Every year, a portion of the deaths happen after everybody has stopped paying attention. Then there is the second category of casualty, which is the person with air conditioning who loses it. During the Eastern Dome in late June and early July, hundreds of thousands of homes lost power. A home that loses power during an extreme heat event does not stay cool. A well-insulated modern house with the windows shut can climb past 90 degrees indoors within several hours on a 100-degree day, and unlike a home in winter, there is no equivalent of putting on another blanket. The people most at risk in that scenario are the elderly, the very young, people on medications that impair thermoregulation, including some common blood pressure and psychiatric prescriptions, and anyone with cardiovascular or kidney disease. If that describes someone on your street, the single most useful thing in this entire video is that you already know who they are. Keep an eye on the grid too, because that is where these threads tie together. When Arizona Public Service set an all-time record of 9,053 megawatts on July 24th, and then broke it again at 9,164 megawatts on August 2nd, utility officials were clear that they had planned for it, had reserves, and were purchasing power from neighboring utilities as needed. That is the system working. But the reason those margins exist is precisely that peak demand and peak stress arrive on the same afternoon. The hottest hour is also the hour when transformers, transmission lines, and generation equipment are least efficient and most likely to fail. Grid stress is not linear. It is fine and fine and fine, and then it is not. So what are scientists and forecasters actually watching from here? The first thing is persistence, not peaks. The Climate Prediction Center's summer outlook, issued back on May 21st, already favored above normal temperatures across most of the United States, with the West, much of the Great Plains, and the lower Mississippi Valley flagged. That outlook is verified. The relevant question for the rest of August and into September is not whether another 115-degree day happens. It is whether ridges keep reestablishing over the same ground before the soil has recovered any moisture. The second thing is the monsoon interaction. In the Southwest, monsoon moisture is genuinely double-edged. It brings a chance of storms, which drops the daytime high. It also raises the dew point, which raises the heat index and critically raises the overnight minimum because water vapor is a powerful greenhouse gas at the local scale, and moist air simply does not radiate its heat away to space as efficiently as dry air does. The August 5th Phoenix discussion described exactly this: slight storm chances, gusty outflow winds, potential blowing dust, high humidity, and morning lows in the low 90s. In terms of pure human physiological risk, a 108-degree day with a 92-degree night and a high dew point is more dangerous than a 115-degree day with an 82-degree night and desert dry air. The lower number is the worse event. The third thing is fire and smoke as heat amplifiers and heat maskers simultaneously. With the interagency system at preparedness level 5, with dozens of large uncontained fires, with a statewide burn ban in Washington and level 3 extreme fire danger posted in the Northwest, the compounding risk is obvious. A heat event that drives fire, fire that drives evacuation, and evacuation that puts elderly people into cars and shelters during an extreme heat warning. And remember, July 16th, when smoke actually suppressed the heating in Pennsylvania. Smoke can lower your thermometer while simultaneously filling the lungs of people whose cardiovascular systems are already under heat strain. A lower temperature reading does not mean a lower health risk. The fourth thing is the Atlantic paradox. A suppressed hurricane season sounds like unambiguously good news, and for coastal wind and surge damage, it genuinely is. But those same systems and the fronts they help drag along are part of how the eastern United States historically gets its heat waves broken. Additionally, and forecasters have flagged this specifically this year, Atlantic sea surface temperatures have been running unusually warm, which favors development independent of the El Niño state. That is why most major outlooks have been balancing two opposing signals rather than confidently calling for a quiet season. Uncertainty in both directions is the honest description. The sixth thing on the watch list is one almost nobody tracks publicly, and it is agricultural and infrastructural rather than medical. Prolonged heat with high overnight minimums stresses livestock, which cannot sweat efficiently and rely heavily on nighttime cooling, and it damages row crops during pollination windows. It also degrades infrastructure in ways that show up weeks later: pavement rutting and buckling, rail expansion and speed restrictions, transformer insulation aging, and sustained load on water systems in regions already managing Colorado River allocation pressure. None of that kills anyone on the day it happens. All of it raises the cost and the fragility of the next event. And the seventh, which is honestly the one I would watch most closely if I were building a personal plan, is simply the calendar. American public attention to heat collapses after Labor Day. The alerts get less coverage. The cooling centers in some jurisdictions begin winding down toward their end of September closure. School and work schedules resume, and people go back outdoors. Meanwhile, the desert Southwest routinely runs triple digits deep into September, and the county data shows a meaningful share of the annual heat death toll landing in that exact window. The gap between actual risk and perceived risk is wider in September than in any other month of the year. And the eighth thing, the longest range item on the board, is what a genuinely historic El Niño does through the fall and winter. The Climate Prediction Center has indicated above normal precipitation odds for much of the southern United States through fall and winter, with the highest confidence over the Gulf states and parts of the southeast into the mid-Atlantic. Analog Super El Niño years have historically tilted the southern tier wetter and stormier, and the northern tier milder. But I want to repeat Noah's own caution here, because it is the most scientifically honest sentence in this entire story. Even the strongest El Niño events do not produce the typical impact everywhere, and a record-breaking event could produce atmospheric impacts never before observed. Nobody has a strong El Niño of this specific magnitude, in this specific ocean state, with this specific Atlantic warmth, in the historical record to compare against. The analogs are guides, not forecasts. So let me close this the way it deserves to be closed, which means being extremely clear about what the evidence does and does not say. America is not about to experience a nationwide temperature catastrophe in the next 2 weeks. There is no credible scientific projection of a 130-degree reading spreading across the continental United States, no evidence of a sudden runaway thermal event, and no meteorologist anywhere predicting that the country becomes uninhabitable this summer. Scientists cannot accurately predict a specific temperature at a specific place more than about a week or two out, and anyone presenting a precise number for September as though it were established fact is not doing science. The heat domes of this summer were severe, they were record-setting in specific places, and they are consistent with what a warming baseline plus a strengthening El Niño would be expected to produce. They are not the apocalypse, and treating them that way actually makes people less safe, because fear that has nowhere to go turns into fatigue, and fatigue turns into ignoring the warning that finally matters. But the most realistic danger here was never the number that makes the headline. It is the number at 4 a.m. It is the overnight low that stops falling. It is the 92-degree bedroom in a house where the air conditioning broke on Tuesday and the repair appointment is Friday. It is the 5th consecutive night that an 81-year-old body does not get to reset, in a month when the daytime headline temperature has actually come down a few degrees, and everyone has decided the emergency is over. Every single one of those 645 deaths in 2023 and 427 in 2025 happened to somebody who almost certainly did not think they were in a life-threatening situation until they already were. The heat dome is not the thing to watch. The recovery window is. And in a summer with a super El Niño building in the Pacific, an unusually suppressed Atlantic, and ridges that keep reforming over already baked ground, that recovery window is exactly what is being squeezed. So check your overnight lows, not just your highs. Check on the person 2 doors down who has lived alone since her husband died, especially in September when nobody's thinking about it anymore. And if you are in a heat relief network area, know that a phone call to 211 in Maricopa County and equivalent services in most major metros will get somebody a free ride into air conditioning, which is a mundane sentence that has already saved hundreds of American lives. Tell me in the comments where you were during the worst heat you have ever personally experienced and what it actually felt like. I read every one of them, and those stories tell me more about how this country handles heat than any dataset does. If this was useful, a thumbs up genuinely helps. Let us get to 5,000 on this one. Let us go. See you in the next one.